In this video, we shall be finding the maximum likelihood estimation from the Gaussian noise distribution given. For more on this topic, you need to subscribe to this channel. So we are asked to find the estimate of A, and that means this A that is given here. And we have this as a distribution. Solution. For maximum likelihood estimation, the first thing to do is to find the likelihood function. So the likelihood function of the given distribution yi is equal to the product sum of the whole of this function, which is 1 all over square root of 2 pi sigma squared exponential yi minus 5a raised to the power of 2 all over 2 sigma squared. So once we take the likelihood function of this, the next thing to do is to take the product sum of the whole of this. That means if we are taking the product sum of the whole of this, we get something like this. The likelihood function will be equal to 1 all over square root of 2 pi sigma squared 1 exponential yi minus 5a raised to the power of 2 all over 2 sigma squared multiplied by 1 all over square root of 2 pi sigma squared. The second one exponential negative yi minus 5a raised to the power of 2 all over 2 sigma squared. Then that is how it will continue. Will give us 1 all over square root of 2 pi sigma squared raised to the power of n, because this will go n times exponential negative. This will sum, it will sum the whole of this to give us yi minus 5a raised to the power of 2 all over 2 sigma squared. So this is what we'll get. If we put the whole of these things together, that means if we multiply this, we take the product sum, we'll arrive at our likelihood function of P yi a to be equal to 1 all over square root of 2 pi sigma squared raised to the power of n exponential negative summation of yi minus 5a squared all over 2 sigma squared. So this is what we get when we take the likelihood function. The next thing to do is to take the log of this function. But before taking the log, the next thing to do is to rearrange the whole of this well. If we rearrange this, we get something like this. If we rearrange this, we get, say, 2 pi sigma squared raised to the power of negative n all over 2 exponential summation of yi minus 5a raised to the power of 2 all over 2 sigma squared. So this is what we get. I running from 1 to n, I running from 1 to n. This is what we get. Nothing has changed from our likelihood function. This is what we get. So we take the log. Take log. It means we get the log of the likelihood function of the given distribution yi and a to be equal to, we can separate this as we are taking the log. We say n negative n all over 2 log 2 pi, we take it one by one, and negative n all over 2 log sigma squared. If you take the log of an exponential function, you get that same function, which is negative summation of yi minus 5a squared, I running from 1 to n all over 2 sigma squared. So we take this as our equation star, if you like. And we are asked to find a. We are asked to find the estimate of a. That means we will now differentiate with respect to a. So we say differentiate with respect to a. So we have log we have the differential of this function log yi a all over dA to give us, if we differentiate this, we get 0. If we differentiate the whole of this, because there is no function of a here, we get what? 0 as well. If we differentiate this, we get negative, we bring out this 1 all over 2 sigma squared. We are differentiating this. So we have these two will come over here to give us multiplied by 2 summation yi minus 5a 2 minus 1 multiplied by, from composite function, we still differentiate what is inside. So if we differentiate a, we get minus 5. It then means that these two can cancel these two, and we'll have this 5 will come over here, negative 5, negative. So we get our differential of log yi a all over dA to be equal to 5 summation of yi minus 5a, 2 minus 1 is 1, all over sigma squared. So this is what we get. The next thing to do is to equate the whole of these to 0. For maximum likelihood estimation, the next thing to do is to equate the whole of these to 0. So we come over to this place. So we say equate to 0. It then means we'll have 5 summation yi minus 5a all over sigma squared to be equal to 0. Of course, this is also 5 summation yi minus 5a is equal to 0. You should also know that, but 5 is not equal to 0. This is also the same thing as if we divide both sides by 5, we get summation of yi minus 5a to be equal to 0, which implies that we need to sum the whole of this. When we sum this, if we sum y, we get summation of yi. If we sum this, since the whole of this is a constant, the whole of this is a constant. So if you sum a constant, you get n times that constant. So you get minus n 5a to be equal to 0. Of course, this can go over to this side to give us summation of yi minus, summation of yi to be equal to 5an. Of course, we can now make our a the subject of formula to become our estimate. So a estimate will be equal to 1 all over 5 summation of yi all over n, all over n. This is what you get. You can still write it as 1 all over 5n summation of yi as I run from 1 to n. So the estimate of a, we are asked to find the maximum likelihood of a. The maximum likelihood of a estimate is equal to this. So this is how we can obtain, for this question, the estimate of a. For more on this topic, you need to subscribe to this channel.